Yes, hey, welcome back. Now let us solve the problem. Segregate odd and even notes in a linked list. And yeah, the question is again pretty straightforward. You're given a linked list and you're to modify the linked list in such a way that all the even numbers appear before all the odd numbers in the modified linked list. And the order of appearance of numbers should be the same. Like if you see the example, you have 17 and 15, and in the output example also, like you see that you have 17 and 15 together. So that is what the order should be maintained means. And note is that you should not create a linked list, new linked list. You should rearrange the provider one itself. So let's disregard the node for now and try to do it naively. In other words, we'll create two linked lists, and what we'll do is that we will link them after we do the modification, and let's see how they have done it. And yeah, they are giving the head, and new head is OBS to divide. That means that we can actually modify the linked list also. Like if you want to check if you have modified it or not. So odd and even will actually be node with value none. Yeah, this is again the naive way, and you will have odd comma even pointing to odd comma even, and while head exists, if head dot data modulo 2, this is pretty simple, is equal to 0, that means it is an even node. So you dot next is actually equal to head, else o dot next is actually equal to head, and then head is equal to head dot next. And so now what you have to do? First you have to return the even node. So what you have to do? So you have to take the even last node of the even linked list and take the next value of it and then set it to the beginning of odd. So odd dot next, and you have to take the last node of odd, which is pointing to go, and odd dot next, and it should point it to none, and you have to return even dot next, because again we are using dummy pointer, and let us see if it works. And yeah, I don't know why it's small over here, so let's just make it small. Mm, okay, this is the reason they have made it so that you can't create new nodes itself, just to make sure that you don't disregard the stuff that what do you call. Yeah, they made it so that you can't insert new nodes at all. You can't create new nodes at all. So that should not be able to create links. But again, there is a workaround around that, and that is that will not put data at all inside the new node. Now you can proceed. What is this? And I forgot to modify the list. E is equal to e dot next, and for odd you have to do the same thing. And now we'll see if it works. So this is the most naive way to do it, and you're not supposed to do like this. And I can't believe it's PLEing. I don't know why it's PLEing. Um, yeah, we should theoretically not PLE because we are modifying everything. But well, this is actually not the way to do it also. So let's not do it now. So now let's go on with the actual implementation. So what we have to do? We have to take all the odd nodes and place it first, and take all the even nodes and place it afterwards. And we have to take care of the fact that we should not create a new linked list. We have to modify the original linked list itself. So first, what we will do is we will get the pointer for the first odd and the first even node. So initially we will have odd is none and none, and that is nothing but even. Even is also none, and we will have curve pointing to head. And while curve exists, if curve dot data modulo 2 becomes equal to 0, that means it is an even node. So even is equal to curve and then break, else curve is curve dot next, and again curve is actually equal to head. And while curve exists, if curve dot data modulo 2 is not equal to 0, that means it is an odd node. So odd is equal to curve and break, else you will do curve is equal to curve dot next. So now you have ensured that you are pointing to the first odd node and the first even node, and that is given now. So what we'll do, we'll have two pointers pointing to the first odd and first even node. So odd comma even is actually equal to odd and even value. And again, see, the issue is that since we are already pointing to the first node and we have to again traverse the linked list from the beginning, we have to make sure that we don't count the same node twice. So, but let's have so we should make sure that we will not point to the same node twice. Like since 17 has already been considered once, and since we are beginning from the head part itself, so 17 will be considered again. So we have to make sure that that does not happen. So we'll have first odd, first even to be initially set to 0. And what we'll do while again the curve exists, if curve dot data modulo 2 is equal to 0, that means it is the first even node. So we'll just make sure that we'll keep the first even node. So in other words, if fe is equal to 0, then we'll just set fe to be equal to 1. Else what we will do, we will consider with our what we call logic. So what we'll do, now you are actually pointing to the second even node, and that second even node has to be linked to the e part. So what we'll do, e dot next is actually equal to curve, and e is equal to e dot next. Else what you'll do, you'll do the same things again. So but we have to again skip the first odd node. So if f4 is equal to 0, then just set f4 to be equal to 1. Else what you will do, o dot next is actually equal to curve, and o is equal to o dot next, and at the end you will do, end of everything you will do, curve is equal to curve dot next. And now what you have to do, the connections have been made, but the odd and the even node are disconnected, so you have to connect them. So e dot next, since we have to return the even node first, so what we'll do, we'll return even. But before that, even and odd has to be connected. So even dot next is equal to odd, and o dot next will be pointing to null. Just this might be redundant, but this is just to ensure that the last node is not pointing to anything. And let's just compile and run it once, and that works. And let's just submit it. And yeah, the approach works. And again, I don't know why just iterating to the list also gave us a TLE over there, but hey, and yeah, that's all for it. And thank you for watching, and goodbye.